Hey everyone, welcome to my channel. Thanks for watching. I'm thrilled that you're here today. We are talking about multiplying polynomials. My name is Bradley Bush and I'm excited to be with you today. Let's start. Multiplying polynomials. So when we multiply two polynomials, we multiply each term of one polynomial, and you get to choose which one you're referring to, by every term in the other one. So if we have two polynomials, we pick one and then we take each of the terms of that polynomial and we multiply it by every term in the other polynomial. And then we just simplify and combine like terms. So this is a general strategy for multiplying polynomials, and it will work for every single case that you have. So it's a fantastic one to learn. Let's start with, we've got a lot of examples here. Let's start with example here A. So we're multiplying two monomials, and we have negative 8x cubed multiplied by 4x squared. When we're dealing with the monomials here, we really are just using the commutative property of multiplication and just moving around stuff. And let me show you what I mean. Let's put all the numbers together. So we have negative 8 times 4, and then with the x's. So we have x cubed times x squared. So negative 8 times 4 gives us negative 32. And when we have two terms with the same base, we add the exponents. So this gives us x to the 3 plus 2, which is 5. And we're done. Not too crazy. Let's do the next one. Again, we have two monomials, so we're just moving things around. So let's put the numbers together. So we have 5 times 4. Let's put the x's together, x times x. And let's put the y's together, y times y squared. So this gives us 20x squared, because they both have a 1 as their exponent. And y times y squared is y to the 1 plus 2, which is 3. So we had 5xy times 4xy squared, and the answer is 20x squared y cubed. And if you have questions here, please leave them below in the comments. I'd love to hear what you think. The next problem, C, is negative 3y times 4y. So you can guess we're doing a similar thing, right? So negative 3 times 4, and then we have y times y. This one might seem a little bit easier than the other ones we've done. Negative 12y, they both have 1 as the exponent, so 1 plus 1 is 2. Negative 12y squared. And D, let's do D. So D, notice we have different variables in our terms. It's not a problem at all. We can handle this. So we can get the x's together, so we'll have a negative out front, and then we have x times x, and everything else, we only have a y and a z in the second monomial in the second term, so we'll just carry those over. Y squared z. So we start out with negative x, and that's multiplied by x times y squared z. So we have negative x times x y squared z. And the x's can be combined. We have a negative out front. The x's give us x squared, and then we just have our y squared z still hanging out. And that's it. What if we were multiplying a monomial with a polynomial? So something that has more than 2 or more terms. We just need to remember that we're really just distributing. So that monomial out front just gets distributed to every term of the polynomial that it's being multiplied by. So in our first example A, we have 3x to the 4th, and that is being multiplied by the polynomial 2x squared minus 3x plus 1. And as we do this distribution, 3x to the fourth and 2x squared. We're going to go a little bit faster here because we saw how we combined in the previous examples, how we combined the variables together and the numbers together. So we're just going to do that here verbally. So 2 times 3 is 6, and x to the fourth times x squared is x to the 4 plus 2, which is 6. So we have 6x to the sixth, then 3x to the fourth multiplied by negative. 3x is negative 9, x to the fifth, because 4 plus 1 is 5, and then 3x to the fourth times 1 is just 3x to the fourth. And we're done. Again, we're going to do another one. Again, we just need to distribute that monomial out front through every term in the second polynomial. So here in example B, we have 2x times the polynomial 3xy minus 4x squared. So 2x. So 2 times the 3 gives us 6, and we have x, and x gives us x squared, and we have a y hanging out there, so that'll just come along. And then we have 2x times negative 4x squared. So the 2 times the negative 4 gives us a negative 8. And the x squared give us x cubed. And we're done. So we can handle these multiplications if we just have one variable, or if we have multiple variables, like x and a y, like we did in this example. Not an issue. This one looks like it's our longest so far, but we're still same idea. There's a monomial out front, and we're multiplying it by a polynomial, and this one has 4 terms. But we still just multiply through each of the terms and then combine. And here we're doing the combining step in our head because we got used to it in the first 6 examples that we've been doing. So here we have negative 5xy multiplied by the polynomial 3x to the fourth minus 4x squared plus y plus xy. So negative 5xy times 3x to the fourth. The negative 5 and the 3 give us negative 15. The x and the x to the fourth give us x to the fifth. And we have a y hanging out. So that's the first term done. Negative 5xy times negative 4x squared gives us positive 20. X to the third. And then the y is hanging out still. And then the third term, negative 5xy times y, gives us negative 5x, and there's a y times a y, so that's y squared. And the fourth term, negative 5xy times xy, gives us negative 5x squared y squared. And we're done. Let's do another. This is 3x multiplied by 2x squared plus 4x minus 1. And again, we're just distributing that 3x through everything. So let's do it. So negative 3x multiplied by 2x squared gives us negative 6x to the third. Negative 3x times 4x gives us negative 12x squared. Negative 3x times negative 1 gives us positive 3x. And we're done with that one. So what happens if we make it a little more complex now? So we've done the monomial case, so 2 monomials being multiplied together. We've done the monomial and some more complicated one. And now what if both of the polynomials are complicated, or meaning at least 2 terms? Well, we just follow this same pattern. It just takes us a little bit longer. So here in example A, we have a binomial, so 2 terms, 5x minus 2, and that's multiplied by a polynomial with 3 terms, 3x squared plus 2x minus 4. all we're going to do is multiply. We'll take the 5x, the first term in the left polynomial, and we multiply it by every term in the right polynomial. And then we'll take the -2 and we'll multiply the -2 by every term in the right polynomial. So it's exactly what we did before. It's just before we just had one term we were multiplying through, but now we've got two terms. We multiply them both through separately, and then we just collect the terms. We just combine like terms and we're done. That's it. Not a problem at all. So let's try. This first one, we're going to start with the 5x, multiplying the 5x through. So 5x times 3x squared gives us 15x to the third power. And then 5x times 2x gives us 10x squared. And then 5x times -4 gives us -20x. And now, if I'm going to change colors here. Because we're going to multiply the -2 through. So -2 times 3x squared is -6x squared. -2 times 2x is -4x. -2 times -4 is +8. Now we just collect like terms and we're done. So let's do it. This gives us, we only have one x cubed term, so we just bring it down. We've got an x squared, a 10x squared, and a -6x squared, so that gives us +4x squared. And the x's, we've got a -20x and a -4x, so -24x. And that's it, besides the +8. So we're done. We're done. That's a little larger box than I wanted to make right there. So it's just one extra step, but it's nothing new. We're still distributing and multiplying, collecting terms. That's it. Nothing too crazy. So again, let's do the same thing here. We've got a similar problem for b. We've got 2x squared plus x is the first polynomial, and the second polynomial is x squared minus 4x plus 3. And we're going to distribute each term in the first one into every term in the second one. So 2x squared and x squared give us 2x to the fourth. 2x squared and -4x give us -8. X to the third. 2x squared and 3 give us 6x squared. That's kind of a funny looking 6 there. Let me see if I can fix that. Now let's do the second distribution. So x times x squared gives us x cubed. And x times -4x is -4x squared. And plus 3x. And now we combine our terms. So we have x to the fourth, only one x to the fourth. Okay, so we'll just leave that one by itself. X to the third, we've got 8, -8 here, and a +1 there. So we have -7. And x squared, we've got 6 here and -4 there, so +2 x squared, and then we have a +3x, and that's it. And if you have questions or comments, I'd love to hear what you think. You can leave them in the comments below. If you're enjoying this, if it's helpful, I'd love it if you would give me a like and subscribe to the channel. All right, the next one, we've got two binomials. So we've got two polynomials with two terms being multiplied together. The first polynomial is 7x squared minus 2. The second polynomial is 3x squared minus 5x. So let's distribute again. Again, we're doing the same thing. We're just using the general multiplication strategy, and we're taking each term in the first polynomial and multiplying it by every term in the second. So the first polynomial is 7x squared minus 2, and the second polynomial is 3x squared minus 5x. So 7x squared times 3x squared gives us 21x to the fourth. 7x squared and negative 5x is negative 35x cubed. Change colors because we're doing the second distribution now. So negative 2 times 3x squared is negative 6x squared. And negative 2 times negative 5x is positive 10x. And now we're just combining like terms. We have, actually, we can't do anything there, right? There's nothing we can combine. We have 1x to the fourth term, 1x to the third term, 1x squared term, and 1x term. So we're done. We just box it and we're done. How about D? Let's do D. So here we have another binomial multiplied by binomial, and we have different variables here. So the first polynomial is 3x squared plus 4x, and the second polynomial is y minus 2y. So it doesn't matter that we have different variables. We're still using the exact same technique. We take every term in the first polynomial, multiply it by everything in the second. So 3x squared times y is 3x squared y, and 3x squared times negative 2y gives us negative 6x squared y. Change colors. We're doing the second distribution now. We have 4x times y is 4xy, and 4x and 2y, negative 2y is negative 8xy. And now we combine like terms, and we have 3x squared y and negative 6x squared y. Those are like terms, so we can combine those. We have 3 and the negative 6. That gives us negative 3x squared y. And we have 4xy and negative 8xy, so we are in the negatives here, negative 4. 4 minus 8 is negative 4. And we're done. We're done with that. And we have one more. This is our bonus. This will be our last one. This is 3 polynomials that are multiplied together. It's it might seem a little intimidating, but it's really not bad. There are 3 binomials. The first is x plus 2. The second is x minus 3. Excuse me. And the third is 5x plus 1. So you might ask, how in the world do we multiply these? Do we just distribute everything in the first term into all of the following terms? Because that kind of, it kind of fits, right? That's if we're following a pattern, that seems to be a good pattern. But that's not actually what we do. And let me kind of give you some background on why we're going to do what we're going to do. So if I gave you 3 numbers, 2 times 3 times 4, and I said, what is that answer? You would give me an answer, and that answer would be what? 24. So how did you get 24? Did you distribute the 2 to the 3 and then the 2 to the 4? And get 2 times 3 is 6, 2 times 4 is 8, 6 times 8 is 48. Nope, you didn't do that, right? How did you do it? That obviously is the wrong answer. That's not what we did. What we did was we took 2 times 3 and we got 6. And then we took 6 and multiplied it by the 4, which is 24. So we took the first number and combined it with the second number by multiplication, and that guy gave us a new thing. And that new thing we took and multiplied it by the last one. So that's really what we're doing. This is just the same here as saying this is 2, this is 3, and this is 4. We're gonna combine these two first. The first and the second polynomial, we'll do that multiplication. And then when we're done, we'll have a new polynomial that will multiply by the second. That will multiply here by or the third polynomial. So we'll combine the first two polynomials through multiplication. And then once we're done with that, we'll have a new polynomial that will multiply by the last polynomial. Hopefully, you guys are still with us. With me. This is a long video. Try talking for this long. It's kind of painful. Here we go. Let's do the first multiplication. We have the x and we're multiplying the x plus 2 by the x minus 3. And I'm just drawing our normal distribution arrows. So we have need to change my color. X times x is x squared. X times negative 3 is negative 3x. 2 times x is 2x. 2 times negative 3 is negative 6. Now we can combine like terms that we have a 3, negative 3x and a 2x give us negative x. So we have x squared negative x minus 6. That's the new thing. And then we're going to bring down the 5x plus 1. And now we can continue. But I'm going to move that down a little bit because I need some more room to do my beautiful arrows, my distribution arrows. So I'm just rewriting this a little bit lower. All right. So you can choose which way to do the distribution. You could choose to take, so here I have the first on the left, I have two polynomials. The one on the left is x squared minus x minus 6. It has more terms than the second one does. The second one has 2 terms. So I could flip them, and then I would have a 2 term on the left and a 3 term on the right. It doesn't matter. Whichever way you feel more comfortable with is okay. I'm just going to keep it here. And keep going. So I have x squared times 5x, x squared times 1. Let me actually write that out as I'm doing this. So x squared times 5x is 5x cubed. X squared times 1 is x squared. Now let's do the next term, orange. So I have negative x times 5x and negative x times 1, which gives me negative 5x squared and negative x. And I need one more. So the -6. Well, that's kind of hard to see that color difference. Let's do green. So the -6 multiplied by 5x gives us what? -30x. And the -6 times 1 gives us -6. And now we're just combining like terms. We only have one x cubed. So that comes down. We only have, no, we've got two x squareds. We've got an x squared and a 5x squared. So we have -4x squared. And we've got two x's. And so -x and -3 gives us -31. And then we have -6. There we go. All right, that was amazing. Thanks for hanging in there. Thanks for watching. Hopefully this was helpful. I have a lot of other videos here in the channel that might be of help to you, so please feel free to browse and let me know what you think. Thanks for watching.